following is a production of the Event Safety Alliance.
Hi, welcome to the Event Safety Podcast. This is Danielle Hernandez of the Event Safety Alliance and Furman University. Today, we're going to be talking about counterweight rigging. I am joined today by Ethan Gilson of Entertainment Rigging Services and Rick Boychuk of Gridwell Inc. in Toronto, Canada. And we are going to start the conversation today talking about the history of counterweight rigging. And Rick, you actually wrote a book called Nobody Looks Up, The History of Counterweight Rigging. So why don't you start us off with this?
Well, I did. I came to a surprising conclusion, realization that our counterweight rigging, we had thought evolved out of hemp rigging, the standard hemp rigging, and that it came off ships. It was much to my surprise that I could find no evidence of that going back in history. Yes, in the mid-18th century to the 19th century to the late 19th century, abundant evidence of nautical, but before that, virtually nothing. And so I had to re-examine the hypothesis and discover that our technology really comes out of simple machinery that was used by various trades and whatnot, most notably perhaps stonemasonry. That stonemason machinery from medieval times was copied and adopted and adapted to suit the needs of upstage, including understage and above stage. And the counterweight rigging was really distilled out of that. We simplified the machinery to the point where we ended up with counterweight rigging. When counterweight rigging came, it changed the way plays were staged. And if you can imagine, counterweight rigging was and continues to be relatively expensive. And that some theaters, especially once you get into England, which is a private theater mostly, and the United States, where it was definitely private theater, they would look for a less expensive way to do things. And they didn't develop hemp from that, but because of counterweight, the hemp system came into prominence. And then history being what it is, nobody wrote this down. And
so you're saying that the counterweight system that I have in my auditorium was based off of how they built cathedrals in the Middle Ages?
There's a long stretch, but yes.
There are some changes along the way, but that's the origin story?
That's right. When we take a look at Baroque machinery, we can more easily see its connection to the cathedrals. But then as we move into the 19th century, the gap becomes wider, and so it's less apparent. But when you take a look at them all the way along, you can see that that's the lineage. Further to which, the main piece of evidence suggesting that our stage technology, rigging technology, came off ships is the pin rail. It took me months of reading and looking at drawings to realize that there were no pin rails in Europe. And there still are no pin rails in Europe in any numbers. All the drawings from the 19th century, from the 18th century, from the 20th century show cleat rails. So they didn't even use pin rails. Pin rails go back nautically a long time, but pin rails don't go back theatrically to match. So
for our listeners who may not know exactly what a pin rail is for, can you tell us what a pin rail would be for?
I'm rewriting the book. I'm present.
Just a brief. Since not everybody has experience with pin rails.
I'm working on that chapter right now. We need to lash ropes off. We just tie them off. We need to lash them to something. And that's what the lashing rails are. A pin rail is a lashing rail. A cleat rail is a lashing rail. And only last month I found out that in Italy, they don't use pins or cleats. They just use a plain rail. And they have a very specific lashing method that they use. And
so similar to when you're docking a boat and you tie it off to that little cleat that's on the dock.
That's right. The techniques are similar, but the applications are completely different.
Of course. And the forces are going in different directions.
They are. But anyway, the development was actually the machinery, the distillation of the machinery into counterweight, and then the heavy adoption of hemp rigging because of the advent of the fly tower. One of the questions in my research, when did the fly tower come into being? And so I started to research that, and maybe 1830s, as we know it today, the fly tower. So we didn't need hemp rigging before that. Anyway, but another remarkable feature of the history is that we developed something to solve the problems of today, and then realize, we can also use it for this other thing. So we use it in a way that was not initially intended. And so the counterweight rigging system, I hypothesize the components of the counterweight rigging system were really not intended to have the weights moved often, maybe even at all. When we take a look at the Clancy catalogs historically, we see that he offers the counterweight arbor for counterbalancing the fire curtain. And then 3 or 4 years later, they say, you can add a second. I should mention, the counterbalancing of the fire curtain took place on the upstage side of the proscenium wall, not at the side wall. So on the and in many theaters, possibly your own, you'll go in there and you'll see the fire curtain is counterbalanced by a counterweight on this ladder arbor mounted to the proscenium wall. Well, that was the initial intent. You put it in the fire curtain, you put it in the counterweight, you load the weights, and you leave it forever. Then they said, you can do 2 of these. You can have your main, they used painted drops, not drapery back then. So you can have your main drape on a second arbor right beside your fire curtain arbor. Again, you would never change that or sell them. And so you'd load up your counterweight, you'd run your main, you'd run your fire curtain, you'd never change them. Life is wonderful. They even got subsequently in catalogs to 3 or even 4, but all intended to be permanently installed. So you're not
just like everything else in the theater. We were like, hey, this is a great idea. We can make it better.
Yes. and then by 1918, they said, if you have a clear side wall, you can put a whole slew of these along the side wall. And so, and that's, you're exactly right. That's what we do. Hey, What a great idea. My point being, the arbor, as we know it today in North America, was never initially thought of to be changing the weights on an ongoing basis. Yet, don't we?
That's how we do it.
we adopt, we adapt, and then we make do. And we've made do with that arbor for 110 years, and nobody complains.
It has improved some. In my space, which was built in 1956 or 7, I originally had a wire guide system. I have a 58-foot clearance to the bottom of the grid. So needless to say, in a wire guide, you did get some line sets banging into each other, arbors banging into each other during excited travel. But in 2005, we changed to a T-track, which is so much better. So there have been small innovations along the way that have made the system safer. And later in the podcast, we'll talk about where stage rigging is going in the future.
Yeah, right. If I may, to put some perspective on that, the original counterweight rigging systems were all guided by tracks in behind. It was when people in the 50s, as your system, people wanted counterweight rigging systems, but they wanted a cheap one.
Yes.
So wire guide was pioneered in the first decade of the 20th century, but it allowed people to have a less expensive counterweight system. Now, as of yesterday, this is probably going to be edited out, but as of yesterday, Mike Hume out in LA sent me an article from 1889, the Inland Architect and News Record. So all these architects in Chicago get together, and the architect of the Chicago Auditorium says that Karl Brandt in Germany had been working on the counterweight rigging system 20 years prior to the auditorium. So somewhere in 1869, Karl Brandt is working on a counterweight rigging system. We found no documentation about that yet. I've been looking for it because I have this hypothesis. Nothing comes out fully formed. The Vienna Court Theater, the first counterweight rigging system, was like fully formed. That doesn't happen. Somewhere somebody's playing.
Somewhere somebody was playing with something.
Prototypes and things like that. I haven't found them. So whenever I refer to the Vienna Court Theater as the first counterweight rigging system, I say the first document. Yeah. Counterweight rigging system.
And it was all metal steel track or cast iron?
It was steel. It was the Vienna Court Theater was in design in the early 1880s. Then there was the Ring Theater fire. There's a ring road within Vienna or something like that. The Ring Theater was on Ring Road, and 600 and some odd people perished in the fire. So the Vienna Council said, no more wooden theaters. And so they had to stop the design of the Vienna Court Theater, and they had to reimagine it in iron. And so the Vienna Court Theater took up until 1888 before it was actually delivered. And so once they moved to an iron structure, they could again look at heavier loads. And then wire rope had been developed in the Hartz Mountain mines. And so they started sort of pulling all these technologies together. Anyway, so it all comes out of safety. Unfortunately, we only learn with disaster, it seems.
Yes.
So anyway,
obvious every day. So for people who don't know, the disadvantage of a wire guide system is that the arbors can swing in motion. And if you have them on 6-inch centers or closer or farther, you can get enough swing where you bang arbors into each other, which can make a frightening noise. But more importantly, you can cause a runaway if you hit it just right and your bricks fall and your load falls to the ground, and it can be disastrous, which is why now systems are going back in either to a track system or going to something more automated. So, Ethan, I know you do a lot of inspections.
Yes, I do.
So tell us a little bit about what you're seeing when you're out. Are you primarily seeing T-track or wire guide, or does it depend on the age of the building?
It depends on the age of the building. It depends on if they've had a renovation in the last few years to decades. The thing that I think a lot of people forget about any rigging system, counterweight rigging particularly, is that it's a piece of machinery. I think the idea of it coming from other machinery is a good way of thinking of it, because it's like anything else. It's like the HVAC system in your facility or the elevator or the escalators. It's a piece of machinery. And as it is operated, it gets wear and tear on it. You then add into the fact that there's human interaction. There's the operation of the equipment. And so when you go through a system, you're going to see both mechanical wear and tear of the system as well as operational deficiencies, maybe a good way of putting it. That is one of the reasons why it is important to inspect your rigging systems annually. In a lot of things, we talk about periodic and frequent inspections. So periodic would be your annual inspection versus frequent would be as you're using the equipment.
Absolutely. So I do know that there are some ANSI standards that provide us guidance on inspections and rigging, counterweight rigging systems specifically. Do you want to talk about, well, let's talk about the system itself first, which is ANSI 2016.
Yes. So that document was, I believe, originally published in 2009 was the first draft, and then revised in 2016. And it lays out both the design requirements for the objects within, or the components of a counterweight rigging system, as well as some operational guidelines that you have to follow or should follow. So, for instance, in that document, it's going to talk about things like the end of your battens are supposed to be marked with a high visible indication, whether that's paint or a vinyl cap, so that as the batten is flying in and out, it's seen. And you don't end up running it into not only people, but other objects within the theater.
Right. There's lots of things you could hit before you get to the people.
Exactly. And there's often a discussion about the aesthetics of a bright yellow 4-inch end of a pipe moving and saying, well, what if you can see it from the audience? Well,
what in the world are you doing if you can
exactly.
see it from the audience?
First of all, redo your masking. But it's important to remember that when you're on stage, either as a performer or a technician, you're working. And you have to take care of each other, and you have to maintain the safety. And especially in a very dimly lit environment, a pipe moving, you're not going to notice it unless the ends are marked. So there are things in the standard for that. There's strength requirements for the components. And it should be mentioned that all of the ESTA standards that are created are available for free through the Technical Standards Program website, which is tsp.esta.org. And
which is a great resource. And
Absolutely.
These standards are written by subject matter experts in our industry, and they're reviewed and updated at least every 5 years.
Yep, sometimes more often. There's a lot of standards, and I know we're going to talk about standards in a future podcast to get into the more nitty-gritty, but they're great documents to help you understand what the requirements are. There's good advice in there how to operate them, how to maintain safety with them. That is something that should be mentioned, is that counterweight rigging systems are, I don't want to say inherently dangerous, but they can be dangerous. There is a certain...
Yeah, so we use counterweight rigging to suspend things above the stage, and then we move them both live during the show and to change them in and out, which we'll talk a little bit more about later. And it's a system that works on balance, so the system has to be in balance, and your operator needs to understand the signs of something wrong and the sounds of something wrong. When I teach people how to operate the counterweight rigging system in my building, I say, there are lots of things in here that if you do wrong, you will hurt yourself. If you do this wrong, you could potentially hurt everyone here. So there's a different level of responsibility when you are not responsible just for your safety, but for everyone's around you. So you really have to understand the forces in motion. And if you're pulling and it stops, well, that's a really big sign that you should not pull harder, that something is wrong. Maybe it's just a spike in the lock. But until you know that for sure, you should not do anything to pull it harder. Sidebar, because that's always what I'm always like, don't pull it if it stops, and always watch it while it's moving.
If I may, I do inspections up in Canada as well. And I've developed some terminology. And to unwrap what Ethan just touched on, I call counterweight rigging systems inherently hazardous. That just comes with it. And potentially dangerous. So I want to... I try to unwrap that a little bit. The other thing about the ANSI standards, which I also point out to my customers, my clients, they are not mandatory. You don't have to do this. But if you ever end up in court, it would be nice to say that you conform.
Right, because they will ask you why you didn't.
That's right. And so... So anyway, those are things that I just like to clarify. It's my spin on it. People don't have to agree with me, but I work with that.
Well, it goes back to the side of there's mechanical wear and tear, and then there's operational sides of it. You're dealing with people. You're relying on people to be trained properly to operate the equipment within its limits. And depending on the size of your venue, and there are a lot of counterweight rigging systems in middle schools and high schools where you don't have the staff support to train people consistently. And the challenge is, you had mentioned, Danielle, about the system is designed to be within weight. And what that means is, for every pound or whatever unit of measurement you want to use of payload, so that might be a light, it might be a piece of scenery. These days, it could be a video element. For every amount of weight that you put on the pipe batten above the stage, you have to, and here's a new term for people, in a single purchase system, you have to have the equal amount of weight on the arbor. It's a 1-to-1 ratio. Now, that term that I just brought up.
The scale.
Exactly. It's exactly the like scales of justice.
Scales of justice.
So
you mentioned a single purchase, which is what mine is, where it's attached to the deck of the stage. What are the other options here?
So single purchase is that 1-to-1 correspondence. So not only is the weight equal, but the travel distance is equal as well. So for every foot that the batten moves, the arbor has to move a foot. You can have what is known as a double purchase system, where the system is rigged with the lift lines to have a mechanical advantage of 2-to-1. So now, if you have a pound of weight on your pipe batten, you need 2 pounds of weight on your arbor. However, that arbor only has to travel half the distance as the batten would travel. And the question is, well, why would you do that? Well, you might have a theater where you don't have the wing space on the side of the stage to put the full counterweight system. You don't have the travel distance. Maybe you have your loading door in the middle of that sidewall, and you want to have a continuous set of line sets every 6 or 8 inches. So maybe over that overhead door, you have double purchase systems. So now your arbor travels half the distance, but the downside is you need twice the weight, which means you have, instead of 2 times your payload capacity as a force on the building, you have 2.5 times that, which has to be considered in the design of the process of the system.
So if you go into a theater and you see the locking rail, the place where the operators stand and pull the ropes on the stage level, it's a single purchase system most of the time. And if it's up above, it's typically a double purchase system. I have heard tell of a triple purchase system, but I've never actually seen one in real life.
You can do that. There is, when we do trainings, when we're teaching people about rigging math, quite often we're creating a utopia. We tell people ignore friction. There is friction in a rigging system, in a line set system. And at some point you have diminishing returns. You can go 5-to-1. Well, you did have so much friction in the system, you wouldn't be able to overcome inertia. You wouldn't be able to
move.
When
something's muled.
Exactly. So typically it's single purchase or double purchase. Those are the common systems. It's important to kind of understand the difference between them and how they behave. But overall, their basic operation is the same. You have an arbor which holds counterweights. It goes up and down the wall through whatever tracking system. It's connected through a series, usually of wire rope, and then pulleys, what we call shivs, at the top of the theater that divert the direction of that wire rope down to the pipe batten, which traditionally these days is Schedule 40 iron pipe of a certain size. And that's what you hang your scenery, your drops, your lighting, whatever it is, you hang them on those. So as the arbor goes up and down, as you pull the rope, you're moving the arbor up and down the track. It happens to be connected to this pipe batten, so it's going to travel in the opposite direction. So when the arbor goes towards the top of your ceiling, the pipe comes down towards the floor. And that's
how the magic happens. We've just ruined it for all the people who didn't know how counterweight rigging systems work.
Yep. And it's a fun kind of, and this is semantics, but some of us riggers really like to get into this nitty gritty, which is that's one of the technical differences between counterweight rigging and hemp rigging, is that when you pull on the rope in counterweight rigging, you're not moving your pipe, you're moving the arbor. Whereas with hemp rigging, when you pull on the rope, it is directly attached to that pipe and that payload. Those sandbags were just giving you some additional assistance to move that rope up and down. It's a small little difference in the mechanics of it, but there is a difference, which is kind of interesting.
That brings it back to the machinery aspect.
Right. If we can just stick with that for a moment, there's an inherent difference. The hemp system and the counterweight system are two different machines. They do the same thing when the audience sees it. The inherent attribute of a counterweight rigging system is that, in essence, your piece and your arbor are in balance. With a hemp system, the piece, your line set must be piece heavy. It cannot operate in balance. You've got to have more weight on your piece side. And then between sandbags and the operator, they add the weight on the operating side. So it's a subtle but profound distinction that makes them two different machines.
All right. So let's now go into the proper ways to do some routine tasks with counterweight, because as we said, it's inherently hazardous and possibly dangerous. So let's talk about the ways to do it right, so that we identify our hazards and eliminate the danger as much as possible. So we're going to kind of do a little list here. Let's start with how we bring a batten into the deck. Batten, again, is another name for that horizontal pipe which holds our load, which could be a light or a screen or a door frame.
Sure, I'll start with this one.
Okay. So, come on, who wants to volunteer?
So typically on a counterweight, modern counterweight systems, that rope that's attached to the arbor, we call an operating line. And that operating line will go through what is called a rope lock. Now, here's one of those other things where the devil's in the detail, which is it's not a break. It is a rope lock. It is not designed.
What's the difference?
Well,
I mean, I know the difference, but I want you to tell me.
So the difference is the object which we touch is designed to keep the operating line from moving. It is a lock. It is designed to stop the counterweight system from being able to move unintentionally or on its own.
So what you're saying is that I can't put a load of like 300 pounds on it and think that the rope lock is just going to hold it in the sky for me.
The standard rope lock is designed to hold an imbalance of no more than 50 pounds, which is not much. That's two and a half Licos, source 4 Licos. A good speaker can weigh 50 pounds. Yep. So it is a rope lock. Now, do we use it as a brake a lot of the times? Yes. You're flying in a backdrop that doesn't weigh much. You get it moving quite fast. You don't want to get rope burn. Instead of slowing the rope down with your hands, you use the rope lock and you use it as a brake. There's some
adds a little bit more friction to it.
It does. And the downside is you can overstress the rope. You can create some local wear and tear on the rope as it's running through the rope lock. And it also eventually will lead to your rope lock not being adjusted correctly and not holding as it should that maximum of 50 pounds of imbalance. So getting back to your original question is of how do you go into to lower the pipe end to the stage level, you're going to go over to your rope lock. There's usually a safety ring that holds the lock handle from being able to fall open. And when you get to older systems, the wear and tear of the components, sometimes gravity can pull a rope lock handle open. If you close it and you walk away, you'll hear clunk, and that's the rope lock handle opening. And now there's nothing except for the balance itself stopping that line set from being able to move. So usually there's a locking ring that goes around the operating line and the rope lock handle. And the first thing you would do is walk up to the system, take the safety ring off, and very slowly, with one hand on the operating line and one on the rope lock handle, start to release the rope lock.
Okay, I'm going to stop you right there because unless we're in a show, I've got an additional step there.
Yep.
You put your hand on the rope, you take the ring off, you do a visual check of the line of travel of that pipe, and then you say, heads up on stage, line set 12 coming in to the deck. And hopefully people say something like, thank you, line set.
Absolutely.
And then you take the rope lock off.
Absolutely. I was hyper focused on the minutia of
yes. See, that's yes. You're
checking
an
to
expert
make
in
sure
the
your
machinery.
balance. Yeah, checking to make sure your balance was there from the get go.
Yes.
To assume that the system is in balance when you're starting is what I was trying to focus on.
If I may, I found it useful to. In a lot of the thinking that I've been doing, not that I do any more thinking than anybody else, but on those days, I differentiate between performance use and utility use.
Yes.
On everything. So how are we going to use it in performance? In performance, we can, I think, safely assume everything's balanced.
Yes.
Not always, but pretty well. In utility use, not necessarily so. And so testing the ropes to see if they're in balance before you open the rope lock, well, you're going to do that in the utility. By the time you get to performance mode, that should be resolved.
On the other hand, if something has moved in travel and you aren't aware of it and say a drop's gotten caught up on another thing, checking that balance can be extremely informative.
Yes,
and
yes.
I will freely admit that when I'm doing an inspection, I'm usually doing it with a limited number of people in the space. So out of efficiency, I every day don't necessarily call the movement of the line set because there's no one on stage. But
right. And everyone knows that in that moment, that's what you're doing. You're doing a rigging inspection. Yeah. Where in my situation, we may be flying something in to hang a drop or hang a speaker, and other people are building decks or pushing things through, or they're dance teachers. They're there. We've given them a hard hat, but they're there. So it's important to tell them things are moving over their heads.
The key takeaway is when you first release the rope lock, you want to make sure that you maintain a hand on the rope lock handle as well as the operating line, because what you're checking for is to make sure the system is within that 50 pounds of balance. Once you know that, then you can start operating the line set. Now, there's this cool thing of the operating line, which in older systems was manila rope, where you would get the splinters. A lot of people call it. Yep. A lot of people call it hemp. Most of that line that you see, that brown line these days, is actually manila rope, because hemp, for numerous reasons, fell out of favor. One of them being it was hard to get. It became illegal for a long time. But another interesting thing is hemp and manila rope are organic. They are natural fiber ropes. They deteriorate over time. Because of that, usually those ropes would get replaced more often than not because they would start to fail.
So something else I know about those ropes is they would react to the humidity in the environment.
Correct.
Since I'm in South Carolina, that can be dramatically different in the summer and the winter. If I had organic material in my rope as opposed to
synthetic.
A synthetic product.
Yep, exactly. So that either brown, or these days most people use what is called multi-line 2, which is a white braided 3-strand rope that has usually a little red tracer every once in a while. Looks nice and bright when it's brand new, and after some time it gets a little duller. But that operating line is connected to the top and the bottom of the arbor. So when you go to move your line set, when you go to fly it in, you end up pulling down on the section of rope that's closest to you. And that a lot of people refer to as the inline. Now, the thing that a lot of novice users will end up doing is when they want to fly that batten the other direction, they will pull up on the rope, which certainly works, but it's not necessarily the most ergonomic process, nor do you get as much strength in pulling up on that rope. The other half of this operating line, which is further away from you, or towards the wall usually, is the outline. And one of the small jokes that people use to remember that is far out, dude, that the far line away from you is the outline. So when that arbor is further up the wall, you can grab that outline and you can pull down on that line. So now you're pulling down on either the in or the out line. It's a little more ergonomic to operate the line set. Back to your original question of now you've flown
we've flown it in.
This is how the sausage is made, folks. The pipe has come in all the way to the stage floor, usually 4 feet off the floor, depends on the space. Now the system is in balance. You have what is known as pipe weight. The dry weight of that pipe batten is on the arbor. Now it's okay for your electricians to start hanging their lights and doing their cabling. And they do a great job.
So I'm out there. I've hung a series of lights on there. And I've checked the safeties because you should, and because I'm obsessive about stuff like that.
Yep.
So now we have a load on the pipe. Well, now I have 300 pounds on my pipe. This is back to how do I get this in balance again?
Well, excellent. Thank you for telling me how much weight you put on there. So that's actually one of the jobs of the flyman in theater, is to coordinate with the master electrician or whomever is hanging load on the line set to say, how much is the object you hung? Then they will determine, and this depends on the size and material of your counterweight. Usually these days they're steel. They can be cast or they can actually be solid steel. And there's a bunch of different sizes.
Yes. In fact, in my venue, we bought additional weight at some point and from a different source. So we had a summer project where we got a scale and we weighed every single one of them and painted the weight on them, because something that looks like a 20 could be a 30, could be a 25.
That is a beautiful process if you have the time to mark all of your stage weight.
It was summer.
Yeah, absolutely. And right now with limited options for people to do things, that may be a perfect thing to do.
A project that somebody that's still allowed in their space can do.
Exactly. So depending on what your weight is, and it should be mentioned that there are some spaces where they used lead counterweight to get the additional density within a size. It is not very often you see that. However, there are things you need to be aware of if you're using lead counterweight, you have to deal with the fact that it's lead and there are health implications to that. So you hung 300 pounds of lighting on that line set.
I sure did.
I'm going to have in a well-designed counterweight rigging system, I don't want to say proper, you will have what is known as a loading bridge. That is an elevated gallery or catwalk at the height which the arbor is at when the pipe batten is all the way down at the floor. So
we've got that. And excellent. I've got a guy up there who's wearing the appropriate fall protection, and he is, it's actually fall arrest, and he is already clipped in. He is ready to go. Everybody on the deck is wearing a hard hat, and they know he's up there. What is he doing now?
It is good to mention that depending on the design of your system, the railings and all that initial fall prevention devices, that in some spaces it is common for the loaders to actually stand between the gallery and the framing of the counterweight system. So they're standing next to the arbors to load weight. Typically, stage weights are anywhere from 10 to 40 pounds. So if you're loading weight and it's 40 pounds and you're reaching through a railing to the arbor, you may have some dexterity issues, which is what we're trying to avoid. So in some spaces, they will stand in the middle of air, basically, to load the arbors to make sure they don't drop the stage weight. If that's the case, you have an appropriately designed fall arrest system, as Danielle mentioned. So what I would do if I was on the floor and I was the flyman is I would, through whatever means, a radio or hollering up, I would tell the loaders to load line set 1, 2, 3, 12 and again, depending on your theater and your specific terminology, it could be, I'm going to tell them the specific weight, load it to 300 pounds above pipe weight. Or maybe I'm going to tell them, load it to 25 and a half bricks above stage weight. So I'm telling them exactly how many counterweights to place on the arbor. Once they do that,
communication is really important at that time.
Yep. And here's a critical part. And you mentioned this earlier about a term that I'm going to bring up in a second. The next thing I'm going to do is I'm going to clear the rail. I'm going to create a safety zone underneath the loading gallery next to those rope locks of a certain distance. And I'm going to ensure that nobody comes and stands underneath that area while people are loading these 10 to 40 pound weights above their heads. So that if someone does drop a stage weight, there is zero chance of you dropping that brick on someone. Now, we talked about wearing hard hats and other things. The first thing that we can do to mitigate the hazard is to eliminate the hazard. If we don't have a person underneath, they can't get hit. Now, the term that you brought up earlier that I just referred to is called a runaway. There are two things that can happen to a counterweight line set when it's being loaded. The first is the loader would just drop the weight and it bounces down between the arbors. And it's like those games where you drop the ball down and it hits all the pegs. You have no idea where it's going to go. And if you drop a 40-pound weight at 65 feet, let's say your space was, you had mentioned yours is 50-ish feet, I think?
It's 58 to the bottom of the steel. So they're another few feet above.
50 feet. Drop 40 pounds from 50 feet of solid steel, bounce it around, and see where it ends up.
Thank you. My imagination can fill that in all by itself.
That stage weight can end up halfway across the stage by the time everything is done, which is why we create that large safety zone. The other thing that can happen is if your system is imbalanced improperly, and here's where I'm going to get to this procedure part, you have what we call a runaway. The arbor runs away uncontrollably. Usually that is the arbor traveling down. If it was happening in this situation,
so in this situation, you would have added the 300 pounds.
Yeah, the 300.
And then I take all the lights off because
let's say there's miscommunication.
We're going to put it somewhere else.
Or you said 300 pounds and I heard 600 pounds. I got confused and I communicated the wrong thing. That line set's going to move. That arbor is going to come down towards the floor. It's going to do so at a rapidly increasing speed until it hits the bottom of the system. And at that point, it's going to make a large noise and highly likely things are going to break and things may start flying around the stage again. And you have that same situation. So the joke is, if you hear run away, run away.
Yeah. And don't just run out of the space. You don't want to be there when things go sideways and down.
A well-known teacher and expert in the field, Jay Garland, used to tell a story of being in a space where they had to run away, and he ran away and he jumped into the pit. And as he did so, he looked up to see a stage weight fly over his head. So that safety zone is very critical, assuming everything goes well.
We did it. We're great.
The counterweight gets loaded properly. Everyone does their job. The system so far is in a happy condition. The important thing for the loaders to remember is to put that locking plate back down on top of the arbor and tighten the thumb screws. That helps ensure that if you have a runaway, those counterweights have a better chance of staying in the arbor. And then the next step is the same as the very first step. You're going to check the balance of the system. You're going to carefully, again with verbal warnings, unlock the rope lock and check to make sure that the system is in balance. Now, we already established we did a good job. We're in balance.
But I was wrong. It was actually 275 pounds. I miscalculated cable weight. I'm sorry.
Well,
I mean, it's not huge problem, but
when I undo the rope lock, I noticed that the arbor, the pipe wants to go out a little because we put an extra 30 pounds. So I instantly attach the rope lock again, or engage the rope lock, I should say. And then I communicate up to the loaders, hey, I need you to take X amount of weight off. So it may be a brick, a half brick, whatever the terminology is, take off 30 pounds. I clear the rail again. The loaders do their job. They take off 30 pounds. They communicate to me that they're done. I go back up to the rope block. Again, same procedure. I undo the rope block and I check the balance.
Hey, how are we doing now?
Hey,
did we do it?
We're pretty close. We're certainly within 50 pounds.
Perfect, which means our rope block will hold it now.
Exactly. Now that we're happy, we're good to go. I can fly that electric up out of distance and we can move on to the next project.
All right, so let's talk a little bit about inspecting before we wrap up for the day. So you both do inspecting. Rick, you want to tell us a little bit about what you look for?
Well, I start with the ANSI standard, and I've created a spreadsheet that reminds me of everything that I have to look for, and I document it for each line set. And it's a good start. It's almost all you need. Then you kind of need a little bit of experience as well in looking at some of these things. For example, the ANSI standard does not. I can't remember, Ethan. If I see rust on the lift lines, I know it's time to change it. End of discussion. I don't know. I can't remember if that's even mentioned in the ANSI standard. It's just something that I know.
Not specifically rust, but the overall condition of the lift lines. And I'll add to this point, one of the other standards that we use when we do inspections is E1.47, which is the recommended guidelines for entertainment rigging systems inspections. Now, this isn't going to tell you what to look for. It's going to tell you how you want to do your inspections. It's going to talk about how frequently you want to do it. But one of the key things about this standard is establishing who is qualified to perform the inspection. Often, someone doing a full annual inspection is not necessarily going to have all of the skill sets that you want to find in an inspector. You certainly can operate your system. You might have an acute knowledge of how your system is behaving, but that standard establishes what's important for an inspector to have in terms of a knowledge and experience base to be able to perform the inspection.
And I'll let you take care of a little bit of business there, and I'll expand on that. What I found over time is that the skill set to be an operator, the skill set to be an installer, and the skill set to be an inspector are different. They overlap in certain places. It's like a Venn diagram, but they are all different skill sets. So operators don't necessarily know what to look for that an inspector knows how to look for. Ethan has a different background than I have. I'm an historian in the topic, and I can look at how your system fits into time. I've also worked for with a manufacturer, not for. So I understand how these things are built and why they're built that way. I've also made things and installed things. So I've got a particular set. And this is what that standard is looking for. What are your qualifications? They don't say what you have to do. They don't say what you have to have done. They basically want the inspector to be
And personally, I always think it's extremely beneficial for the operators to be there for the inspection. First of all, because you can communicate anything that you've noted hopefully in your rail log, because you should keep one for noting problems and things that come up. But you should also see how someone's inspecting things, because you can always learn how that impacts your day-to-day operations. And
as an inspector, I like to have the operating technicians around so I can ask them questions.
One of the first questions I'll ask people is, how's your system behaving? Are there strange noises that have developed, or is there friction somewhere on a line set that might indicate something that I need to look at closer as I'm doing the inspection? One of the things I wanted to mention is I'll get asked often by owners of a system, whether they're the operator or facilities manager, of, what are the common things that you'll find during an inspection? And again, some of that is mechanical things that have have worn over the time period. Sometimes it's operational things. So some of the things that I want to mention that people should take a look for, this is the most common thing that I find is the lack of labeling and signage about the capacity of your system. That ANSI standard 1.4-1 talks about where you have to have signage in your system so that you know how much weight you can put on a line set, how much weight you can put on your loading bridge for storage, different things like that. Loose or missing hardware. So an easy one is on your rope locks. Is the rope lock moving around? Is it attached to its stand properly and not moving? Another very easy thing, and this is kind of an operational thing, is the rope lock adjusted properly? When you close that rope lock to get that 50 pounds of holding capacity, is it too loose or is it too tight? Can you barely close the handle? That's something an operator can adjust to get that sweet spot. And over time, it will change as the rope stretches, as things wear and tear. That's something to look at. A big thing, again, it's an operational thing. So having the operator there is going to be the use of spreader plates and locking plates, which are devices on the arbor designed to help maintain the counterweight in the arbor if it moves uncontrollably. And then one of the other things is worn operating lines. Those ropes that you use to move the arbor, they wear over time. One of the things that you can find if you go to your main curtain, which is usually heavy, especially if it's on a traveler track and goes in and out all the time, is used more than any other line set probably, is what we call high stranding, which is where one of the strands in that rope, that operating line, will actually be over stressed and actually ends up getting pulled towards the middle of the rope more than the other two strands. So those other two strands stand proud of that first one. So it's called high stranding. And you can feel this when you operate your main curtain. When you fly it in, you can feel the rope kind of pulsate in your hand. You can also see it, and I have some good photos that I usually put up on Facebook of high stranding when you can see it. And what this indicates is that operating line has been overstressed. Why does that happen on the main curtain? It goes back to that earlier discussion. People fly the main curtain in really fast, and then they grab the rope lock and they use it as a brake and they slam it on, and they try to stop the main curtain instantly, and that adds a lot of stress to the operating line, and so you get high stranding.
So if you guys see things like that, you should probably either replace the rope and you should have an inspection every year.
Yep.
All right. So we are coming close to the end of our time here. I've changed my mind. We're not going to talk about automated rigging today, but sometime in the future, we'll probably do this for automated rigging as well. There's some really exciting things coming out in the industry today that have eliminated some of the hazards and given us some new ones to look out for. I want to thank Ethan and Rick for joining us today. This has been fabulous. If you guys have any questions or comments, go ahead and email us at info@eventsafetyalliance.org or send us a note on Facebook or any other social media where we are and you are. Thank you all, and be safe, everybody.